Introduction and purpose. This lab is intended to 1. Calculate the mass of a black hole given the orbit and forces by a star orbiting it, and 2. Project a path of a ship as it is affected by both a moon and planet given a starting velocity. Fnet is defined as the sum of all forces, and for this case it is the sum of all gravitational forces by the respective surroundings. The physics principles used in this lab are Newton's second law and universal gravitational forces, and breaking down Fnet into Fnet parallel and perpendicular using curving motion. This experiment is entirely code-based, and the system is the star for the first part and the ship for the second part. The surroundings for the first part is a black hole, and for the second part, it's the planet and the moon. GlowScript is exclusively used for this experiment as it calculates the mass of the black hole and projects the path of the ship given a starting velocity. In this experiment, I found difficulty establishing a figure 8 orbit around the planet and the moon, but I was able to establish a path that was affected by both. Physics equations and calculations. The first formula is uses the initial position and average velocity to find the new position. Second formula uses the initial velocity and Fnet and mass to find the new velocity, and the Fnet is the sum of gravitational forces from all surroundings onto the system in this case. And the third formula is the universal gravitation formula, which uses the gravitational constant, g, the two masses, and the radius to find the force of gravity. The top picture also shows Fnet being broken down into Fnet parallel, and Fnet perpendicular. Result. The top image shows the orbit of the star around the black hole. I found the mass of the black hole to be 1.44637 times 10 to the 34th power kilograms. The bottom image shows the path of the ship in purple and the orbit of the moon in cyan around the dark blue planet. I was unable to get a stable figure 8 orbit, but because the path is not perfectly stable around the planet, the moon is indeed affecting the path of the spaceship. In fact, for the first part, it was zigzagging around the moon. GlowScript analysis. This section of code gives us velocity, and we use that to find change in velocity, momentum, and our Fnet. We then break down Fnet into its components. Then we use all we just found to solve for the mass of the black hole by rewriting the universal gravitation formula to solve for them. We also use the components of the Fnet to model the forces the star is experiencing during the model. GlowScript analysis for part 2. The top code initializes the masses needed and the initial velocity of the ship. It also sets delta t to be 60 seconds. The initial velocity of the ship was 1.895 times 10 to the 4th for the x component and 2.9 times 10 to the 4th for the y component in meters per second. The bottom code initializes position forces on the moon and ship and uses the position and the velocity update formula to track the position of both the moon and the ship. The forces are calculated using the universal gravitation formula. Possible errors and what ifs. Possibly could have chosen a better starting velocity for part 2 to get a more stable orbit, and I possibly could have erred in choosing the mass of the black hole because of rounding issues. What does it mean? The rate of change of momentum could be negative while there is a weaker positive Fnet showing a kind of change in how quickly that the orbit could be accelerating. And what if these two models were combined? Each smaller mass would feel the gravitational forces of all the larger masses, and thus, since the black hole has such a large mass, it would have the dominant effect of gravity in this experiment.